Hi guys. All right, so now we're going to discuss the uses of our fresh water. So as it stands right now, a third of the people on Earth experience water shortages for at least part of the year, if not all of the year. And this number is getting higher. So we really need to examine how we're using our water to determine how we can conserve our water. So we use our water in three main categories: agricultural, which is growing crops, as well as cattle; industrial, so used in industry to produce goods; and then our personal use within our own homes. So the problems we're having with this is in some places we're experiencing too much water. In other places we're experiencing too little water. And then in a lot of places we're experiencing poor quality water. So if we look at this map, it shows areas where water use exceeds their supply. So obviously within the United States, we have this swath of area that has very high overuse. This is our farming communities. This is where the Ogallala Aquifer is that we talked about in the last lecture, where there's not a lot of rainfall here, but it's also where we're growing most of our crops. You would think, well, why do we not grow our crops where the rain falls? Well, the reason why is because the East Coast and the West Coast are highly populated areas. These places have tons of infrastructure for homes and industry and not much for farming. So it's hard to switch the uses from agricultural to urban when you have all this infrastructure built there. You can't just mow down all the houses and grow a farm and then build your houses elsewhere. It's not economically feasible. So instead what we do is we try to divert water. Now we are not the only ones who are having problems with water. If you look throughout the world, this has become quite common. And as our adequate supply decreases, then that becomes a real problem for the human population directly. So using our surface water, most fresh water in the U.S. is surface water. We get most of our water from ponds like Claytor Lake and Carvin's Cove, and rivers, and not so much from groundwater except for agriculture. And around this area we do have wells that tap into aquifers, but most people are hooked up to municipal water, which does come from surface water. We can also divert surface water to make artificial lakes like Claytor Lake. So Claytor Lake is only there because they made Claytor Lake Dam, which is really cool if you ever get a chance to go and tour that thing on the inside. It's really creepy. So you can divert water. Now, diverting water has its own problems. If you're diverting water to one place, you're typically taking it away from another, which is very controversial and can cause a lot of issues. It can also disrupt wildlife. So if you're talking about where some species need to travel to spawn and reproduce, you could really mess up their life cycle, which could cause bigger problems. So you have to be very, very purposeful when you're going to create a dam or canal, and what kind of impact is this going to have environmentally. Drought and overuse is a much bigger issue. This causes water to be completely depleted. So this sea right here, this is the Aral Sea, which is in the Middle East. And this was it in the 1980s, the late 1980s here. You can see it was a huge body of water, the fourth largest body of fresh water in the world. And by 2003, it was like a fourth of the size. And in 2009, this is what's left. And today, there's even less. This sea disappeared because of misuse, okay? Purely misuse combined with droughts, but mostly misuse of the water. They actually landed up diverting some of the water for another use, and in the process destroyed this whole ecosystem, which they were all relying on. And we'll talk more about that in just a little bit. So here we go. The Aral Sea is the fourth largest lake on Earth, like we just said. It lost more than 80% of its volume in just 45 years, which is staggering. The two rivers leading in there were diverted to irrigate cotton fields, but here's the problem. A lot of these people were using that small sea as a source of income for the fishing industry. So these are all big fishing boats there that are stranded now where the sea used to be. So they basically traded off one form of income for another. And so these people that had these huge fishing vessels already in play all went defunct. And now that equipment just sits there not used. And then they had to invest into growing these cotton fields. But the cotton fields could potentially run out of water as well. The other thing that happened with this huge loss of fishing jobs is that when you're growing cottons, they had to start using pesticides. When they started using the pesticides, they had runoff, and that went into the waterway. And then as the waterway shrunk, those pesticides became concentrated, and as the water completely evaporated, it left behind this pesticide-laden dust. And so every time the wind blows, it picks up this dust of powdered pesticides. And as you all know, pesticides are really, really bad for us to be breathing in, can cause a variety of mutations, including cancer. So this is not good for the people in this area. And what's even worse is this cotton industry that they invested in to do this was not enough to regain the economic loss of losing all that fishing industry. So they basically made really poor decisions, destroyed an ecosystem and their economy. So overdrawing our surface waters can be problematic as well and damage our ecosystems. So this is happening in the Everglades. Florida is a very popular place. A lot of people want to live there. And Florida is also an area where we have a large amount of natural wetlands. So if you look down here, all this green is natural wetlands. The problem is we have started to develop housing, put housing communities on top of this wetland. So they go in and they fill up the wetlands and they put all the housing communities here. All right, and when this occurs, the estuaries, of which a lot of species are dependent upon, get too salty because they no longer have the source of fresh water from these bodies of water in here, and so the salt water comes up into there and makes it saltier, which is also not good for us because it makes the groundwater saltier, so you lose access to that fresh water source, and again, fresh water is very rare. So worldwide, the demand for water keeps growing, and yet we're making these poor choices that reduce the amount of fresh water available, because especially in the United States, we turn on a tap, we have fresh water, we feel like it's an abundant supply, and it has been in the past, but that supply is shrinking and we don't realize it because you won't realize it until nothing comes out of that tap. So what this can lead to globally is what's called water wars. So people are leaving areas to have access to water that would normally stay where they were, which causes problems with immigration and immigration. People are fighting over water resources, which didn't happen before as well. This is going to be a commodity, a big commodity, and it already is within industry, and we'll be talking about that later on in this unit as well. So too little water is a really big problem. Places that are arid or semi-arid lands, they are turning into full deserts. Instead of just being dry areas, they're full deserts. So in order to produce food in these areas, you're relying on irrigation, just like we are in the Midwest. If we did not irrigate the Midwest, it could very well turn into desert. And so what you see here, these circles are kind of cool because in the center of the circle is a well. The well goes down into the aquifer. And then they have these long arms with sprayers attached. They go around in a circle, all right, to spray water. That's why they're circular shaped. All right, it would be much more efficient for them to be a square, but it's all reliant on this well. So you can even, if you look close, see the tracks that the wheels go on as you're irrigating the land around and around and around. So again, agriculture is the greatest use of water. It's somewhere between 70 and 71% of our fresh water is used for agriculture. So they need to be as efficient as possible in their use to prevent the loss of water. Because if we run out of water here, especially in the Midwest of the United States, then the agriculture, they don't have any choices. They're going to go out of business, and then people are going to starve. So farmers are very aware of the idea that aquifers could be depleted. All right, they've already been working on this diligently. So they know they're removing the groundwater faster than it is replenished, and that lowers the water table, which causes a lot of problems. Not just the lack of fresh water, but there's other things that can happen too. So one of them is, just like in Florida, that idea of saltwater intrusion if you're on the coast. So as your water is removed, the salt water moves in by pressure, right? You're pulling the water out here, this gets sucked in. And as the salt water comes in, it completely ruins your freshwater supply, anything that was in there. So the salt water mixes in with your fresh. So this is southern Florida. It's a real problem. Florida is at sea level, so saltwater intrusion can happen really easily. So the other thing that can occur with this idea of depleting your aquifers is sinkholes, okay? So 68% of groundwater in the U.S. is used for irrigation, most of which is inefficient. So we're working on this. We're getting better, all right? And we got to keep working on it. If the groundwater is depleted, the falling water tables can cause cities to sink because that water creates pressure underneath there. And when you remove the water, not only does it take sediment with it, but it removes that pressure, pushing back up on the soil, and then you have sinkholes. And we've had sinkholes throughout the United States. Florida has been having quite a few sinkholes, and the most recent one that I could think of that I heard about is there was one right outside of Mar-a-Lago, the golf place that Trump owns. So they had a sinkhole right outside of there. And these sinkholes, they could be anything from something very, very small that's not that dangerous to something huge that swallows cars and houses. So this also causes cities to sink. This is happening on the east coast of Virginia near Portsmouth in Norfolk. So where they're pulling, that large population there is pulling a lot of fresh water out of the ground. When they do that, you don't have that pressure pushing up anymore like you had here, and so the whole city will sink. And the problem with the whole city sinking is, one, it lowers elevation, so you're more likely to have flooding. That area already has problems with flooding. On top of that, as the city sinks, it can mess with the foundations of the buildings and cause buildings to be unstable. And then you're talking about having to rebuild your infrastructure. It can break pipes. It can cut lines. It's really not a good thing and not something that you would want to happen. So here's a little animation of how sinkholes form. So they filled this with dirt, and you can see the water is rushing through just like it would. And when water's moving, because you're pulling it out, it takes some of the sediment with it, and it creates this little bubble here. And if the water level gets low, like it is right now, this sediment might very well start collapsing, right? Because the water's not helping to hold it up anymore. And then once it collapses, the surface will break, and then you'll see our little car fall over right there. So changes in our runoff. So prior to the 1970s, 10% of stormwater became runoff. And that's not a good thing. We don't want runoff, okay? We want groundwater. That's what we need to do, is replenish our aquifers. But now 55% of stormwater is runoff, and that's just because of development. All right, we are very overdeveloped, and we use a lot of cement and asphalt. Okay, so this depletes our permeable soil area, like the development, and so when we lose that, the water can't trickle down. And that's no good. It does a couple things. It doesn't refill our aquifer. It causes flooding. And it also causes this, where your water is running so fast it's picking up sediment. That sediment goes into a larger body of water, all right? And all that nutrients inside your water, that's not good for anything living in the water. And it can actually cause algae blooms. And then when the algae die, it sucks all the oxygen out of the water. That's called eutrophication. And then everything in the water dies. And sometimes you see on TV these big fish die-offs, and they're like, we don't know why the fish all died off. I'm like, well, we know why. It's because the water is polluted from sediment and other things, and you get these algae blooms, and it kills all the animals off. So stormwater, when it's analyzed, contains a lot of nutrients, which doesn't sound like a bad thing, except, again, if you put all those nutrients in the water, it creates algae blooms, which then depletes the water of oxygen and kills anything living in it. It can also be high in metals they found that are picked up from industry and improper disposal of materials. And that's obviously not good, especially if you're pulling drinking water from that source. You do not want heavy metals in your drinking water, so think like lead, okay? Suspended solids, none of that's ever good. Usually it's fecal matter. Pesticides, obviously a really bad thing, very common, especially in farming communities. The runoff picks up all those pesticides and the fertilizers. Things like hydrocarbons, microorganisms that could make you sick. So these things are present in almost 100% of stormwater tested. So they know that runoff is dirty, and they need to come up with some ways to deal with it. And we have come up with some ways. So it's all about water management, and that little guy's just there because he's cute. Water management is, our goal is to have sustainable, which means long-lasting supply of high-quality fresh water. All right. So how do we exactly do this, right? We could go back to building dams that will hold fresh water in reserve for us, but again, that can also have negative consequences. So you have to balance out the positive results versus the negative results and what's best in the long run, because we don't want to land up like they did at the Aral Sea. So that goes with diversion as well. If we divert waterways, that's not what nature intended. Usually it results in something bad like flooding. So we have to be very careful about what we do with that. And then we got desalinization. Desalinization has become more popular. There are some concerns with it though, and they're looking at it in the Florida and California and other countries. The problem is it's very, very expensive to build, and so people are reluctant to invest in it unless you really, really have a high need for fresh water. But right now, the companies that are investing in it are doing it successfully. And we'll talk more about that in a little bit. We're going to watch a video. And then the last thing is to decrease the demand. All right, let's be more conservative about how we're using our water. So here's desalinization, and I will post this video down for you to check out. It's a really good video about desalinization in the United States and in another country and how we're doing it. But basically, this is taking salt water and removing the salt. And if you remove the salt, it turns into fresh water. Some of the problems with desalinization, traditional desalinization, is it takes a lot of energy to boil this water. So you have to boil the water and collect the steam. The steam is fresh water. So they get steam and then they run it through a thing that cools it off, and then they collect the fresh water. And this was the original way they did this. And this was very, very high in energy, and so not very cost efficient at all. The new way they're doing it is they're using filters, all right, like kind of filters in your fish tank, but these little tiny filters that can filter out tiny little molecules like salt, and it's called reverse osmosis, what they're doing, and this separates the salt from it. Now the problem with this is, what do we do with all the salt? And right now they're dumping it right back in the ocean, which is not good, because if this is our long-term solution to fresh water and you keep dumping salt in the ocean, it's going to change the salinity of the ocean, which we're dependent on. If you make it too salty, organisms are going to die. So that's not a good long-term solution. We needed something else to do with the salt if we're going to use this as a form of fresh water. All right, so decreased demand is another thing that we're really looking at. And again, this goes back to both our personal decisions, but even more so agriculture, right? Because agriculture uses the most of the water, so 70 to 71%. So traditionally, they make those long arms we were talking about before with the big sprayers, and this just sprays out. Now, the problem with that is that water on the surface evaporates. So you're spraying out all this water, and a big chunk of it's going to evaporate and not help you grow plants. And it sprays out in high volume and puddles on the ground, and then that just evaporates too and doesn't reach the roots of the plants. So what they're trying to encourage farmers to do is to switch their systems, which does cost money. So from the farmer's perspective, it might be very, very cumbersome for them to financially do that. They'll probably need support to do that properly. But they need to change their irrigation systems to what's called drip irrigation, and this has become more popular with farms and even within the gardening community. And so it's basically long hoses with tiny little holes poked in them. So as the water runs down, it drips water out slowly. And because it's dripping it slowly, it tends to be absorbed into the ground there, and the plants can pick up that water a little at a time. Because if you squirt out a huge bunch, a lot of it's going to be wasted. The plants can't pick it up as fast as it's coming out. So this drip irrigation is very efficient, and will cut the amount of water that we're using for irrigation significantly. The other thing they're saying is to plant plants that grow in your climate. Announcement.
Students that are waiting on bus 66 or bus 169, report quickly to the middle school cafeteria. The buses will be arriving in 5 minutes. Thank you.
So, if you plant plants that are appropriate for your climate, like if you live in a high drought place like California, then what you can do is you don't have to rely on watering them so much because those plants are adapted to that environment. We're also looking at industry and industry working better with its water and conserving water and recycling their wastewater. And then, of course, personal decisions. So back to using those climate-appropriate plants, they're encouraging people to do xeriscaping. And they do this in California quite a bit. In California, they don't have big grassy lawns because a lot of times in most parts of the year, they can't water the lawn, so it would just die, and then they'd have to pay to reseed it or sod it. So what they'll do instead is they will do xeriscaping and put like drought-resistant plants in and rock. In some cases, they even put artificial turf in. That's not as attractive, in my opinion. But by doing this, they don't have to water their plants that much. And it's also, in a lot of ways, better for the wildlife because it creates a variety of food and habitat for wildlife to live in versus just grass. Most animals can't survive on just plain grass, especially sod. If you have clover in your lawn, that's probably good. But if your lawn's a monoculture and it's all grass, it's actually really not good for wildlife. So here's those sprayers I was talking about with agriculture that they just spray the water out. This is incredibly wasteful, it turns out, with water. So we're looking at agriculture, and to reduce this evaporation or seepage, and drip irrigation is the biggest thing right now for us to switch to. We think that's going to work for them. All right, goes straight to the plants, and so it will reduce that by 40 to 60%. So you're talking about cutting in half. So instead of agriculture using 70% of water, they'd be using 35%, okay, which is significant. That puts them on par with industry, almost. It's a little higher, so. But that's a significant decrease that might help us preserve our aquifers for longer. So municipal, which means within our towns and cities, all right, we have lots of solutions that people do. One of the things they can do is you can install a gray water system. So this is not really readily done when you have a house that's already built because you would have to go through and pay a plumber to do all the pipes for this and stuff. So most people are not going to pay the money to do that. But if you're building a new home, when you guys go out and you get houses, if you're building a new home, you can ask for a gray water system to be put in. And if you're doing it as you build the home, it's not going to cost you much at all because you're already running those pipes. You're just going to run them in a different order, okay? So it's not going to cost you much more. And what this gray water system does is it takes dirty water, not from your toilets, okay, but it takes it from like your sink where you're most likely washing your hands and stuff or dishes, from your shower, which you're using so much water versus the amount of dirt that comes off of you, that the water is virtually clean, okay? So the only things that are in there is a tiny bit of soil, a little bit of soap, but it's mostly just water. Also from your washing machine. So all this gray water goes into a tank, and then what they would use this water for is like flushing your toilet. So you'd flush your toilet with water that had soap and maybe a little bit of dirt in it, which who cares? You're going to poop and pee in there, right? And what this does for you, one, it saves you money because every time you flush your toilet, you're not paying for that water, all right? And when you go and get your own home, you do have to pay for your water unless you're on a well, and then you have to pay to maintain your well, and you don't want your well to run dry because that's going to be tens of thousands of dollars to replace your well, okay? So it saves you money. Some places you can see like this one also use that gray water for watering your plants and stuff because again, any of the pollutants that are in there, any of the soap is so watered down at that point that it's not going to do anything to your plants, and you don't have to pay for that water. You're not paying for twice the amount of water. So you're just reusing it once more before it goes back into the system. So economically, a really good choice for you if you can get it in as you're building a house. Economically right now to redo your pipes to put this in most homes is not the economically good choice. But new houses, this should be in every new house, in my opinion. All right, education is another solution so that people can change their habits, like we're doing right here in this class, learning about these different techniques that you could do to change your habits. Water saving fixtures and appliances. So if you go in to buy appliances, when you guys go out and get your homes, you can look for water efficient appliances. And so these appliances in the long run will save you money on your bills, which is the big thing to get consumers to buy into this is, okay, I don't want to have a really high water bill or a very high electric bill. If you want to talk about that kind of efficiency, let me look for something that doesn't do this. So they have high efficiency toilets. So I have one of these in my bathroom, a high efficiency toilet. So pre-1980s, the toilets, every time you flush, that was 5 gallons of water that you're flushing down and that you're paying for, okay? And so the high efficient ones, they don't use as much water, and they're designed, to get the same amount of force, but for less water. So you're using a little over 1 gallon. That's a huge savings in water, which translates to savings on your water bill. Now, if you have an old toilet, like when I moved into my first apartment and I was super, super broke because I was a teacher and I wasn't married to my husband yet, one of the things you can do with an old toilet is take off the back of your toilet and you can put a brick in the tank. And by putting a brick in the tank, it takes up space, right? So there's less water in there, so every time you flush, it's a little less water, a little less on your water bill, okay? Make sure you're repairing any leaks. If you have leaks and you're not taking care of them, you're like, well, I don't really want to pay to repair the leak, but then every second that it's leaking, it's costing you money because you're paying for that water. All right, another thing you can do is cisterns, which we have like here at our school, right outside of our greenhouse, is now a giant cistern that Mr. Filer had put in so that our roof of our greenhouse collects water, it fills the cistern, and then we can use that to water our plants. So the school does not have to pay for the water we use to water our plants now. Okay, that's all reused rainwater. You can also do this at home with rain barrels. They're really cool. I love them. Oh, by the way, here's a toilet. I like these ones too. I don't have one of these. It has 2 buttons. So like if you're just doing a pee, you just do 1 button. And if you have to do a poop and you need a little extra water, you're going to do 2 buttons. All right, so you could do 2 for number 2 and 1 for number 1. Here is the water barrels. So as water falls onto the roof, your gutters that are already there, you cut them a little short, and it drains into the barrel, and you do got to put a screen on top of the barrel because you don't want a bunch of leaves in there. You just want water. And they raise them up because it's gravity that's going to push the water down through your hose. So the water doesn't come out with force from these, so it's not great for spraying water, but for watering your plants nearby and your little gardens and stuff like that, perfect, okay? So you go in there and the water comes down, and I used to have one of these outside of my garage until a tree hit my garage and then it killed that too. So I need a new one. So one of these goes down, it fills with water, and that's free water. It's rainwater, okay? It keeps it from flooding because you're absorbing that water, holding onto it, and then you use it later when you need it, all right? So it's good all the way around.